Okay, so we're going to be working a problem out of the Serway Text 7th edition. This is out of Chapter 5, page 129, number 21. This is the problem as illustrated in the book. This diagram is given to you. The givens that we have is that the system is in equilibrium and that this weight hanging at the end is F sub g, or force of gravity. So what they want us to do is show that T1, the tension in this cable, is equal to this right here. So the first thing we're going to look at is a quick free body diagram of the weight hanging down here. And we can see it's really simple. There's no left or right, so there's no x's involved. It's just up and down. We can see the sum of forces for y is T3 minus Fg, which equals 0 because we're in equilibrium. Therefore, T3 equals Fg. So now what we need to do is draw a sum of forces for the rest of this system. And I'm going to choose this knot right here as my particle that I'm going to model. So I'm going to call this FBD sub knot. And I'm going to draw my knot. I've got one coming up here, that's tension 2. I've got a cable coming up here, that's tension 1. And I've got a cable going straight down, that's supposed to be straight, that's tension 3. Okay? So I'm also given that if my ceiling is up here, this angle is theta 2, and this angle is theta 1. So the first thing I'm going to do is I'm going to look at this and I'm going to say, you know, if I reorient my axis at that knot, I can see that this theta 1 here is equal to this theta 1 down here. And theta 2 up here must also be theta 2 down here. Now that I've got that oriented, I can start figuring out the components for these two tensions. So if I imagine my right triangle dropping down here, dropping down like that, I can start to analyze this a little bit more. So let's start with our x's. On this side, I'm on tension 2, so my x on this one is going in the positive x direction, so I've got my magnitude T2 times, this is the adjacent angle to the theta, so cosine theta 2, okay? And my y going up here is going up, so I have, again, my magnitude T2 opposite sine theta 2. Moving to the other side, my y direction still moving up, so I have this time T1, opposite angle from the theta, so sine theta 1. Now going on my x, this time I'm moving to the left, so this is the negative x direction, magnitude T1 times the adjacent, so cosine theta 1. Now that I've got all my parts here, I can start to analyze my my equations here. So what I'm going to do is come over here and start with my sum of forces in the x direction. And we're just going to look at what we've got going on in the x direction. I've got a negative actually let me write that in the same color it was in. I'm going to say negative T1 cosine theta 1 is going to get added, because this is positive, to T2 cosine theta 2. Okay? This is going to equal 0 because we're in equilibrium. Therefore, T2 cosine theta 2 equals T1 cosine theta 1. That's all we got going on in the left and right direction. So now let's take a look at our y direction. Sum of forces in the y direction. We're going to do red for y. I've got a positive T1 sine theta 1. I'm going to add T2 sine theta 2. But I've got this one pointing down too, so I now have to subtract T3. And again, we're in equilibrium, so this all equals 0. Now a minute ago, we said that T3 equals F sub g. So if I consider that, I can put that in here, and I can move this to the other side, and I can say F sub g equals T1 sine theta 1 plus T2 sine theta 2. So now that I've got my equations, I need to try and get T1 isolated. That's what we're looking for. So in order to do that, the first thing I want to do is I want to try and get as much as possible in terms of T1. So this T2 here is messing me up. What I want to do is I want T1. So I'm going to take T2 and put it in terms of T1. So if I go back up to my x equation, I can see I've got T2 here and I've got a T1 over here. Well, just your normal algebraic manipulations, I can say, well, if I divide each side by this cosine of theta 2, I end up with T2 all by itself. So I can say T2 equals T1 times the cosine of theta 1 over the cosine of theta 2. Now that I've got that, I can take this term for T2 and I can plug it back into my T2 over here, and I'm going to end up with an equation that has all T1s in it, so I can simplify. So if we move over here and we plug all that in, I'm going to have FG equals T1 sine theta 1 plus T2, which is this, T1 cosine theta 1 over cosine theta 2. That was my T2. I still got this sine over here, though, sine theta 2. Okay? Since this is multiplied, quick cleanup, I can just put this sine on top of this, cosine times sine, and I get F sub g equals T1 sine theta 1 plus T1 cosine theta 1 sine theta 2 over cosine theta 2. Now I want to get T1 by itself, and I notice I got a T1 in both my components here. So I can factor that out and say FG equals T1 times sine of theta 1 plus cosine theta 1 sine theta 2 over cosine theta 2. Well, now that I've got T1 isolated, I can get it all by itself by dividing both sides by this whole big ugly thing. And I can end up with T1 equals F sub g over sine theta 1 plus cosine theta 1 sine theta 2 over cosine theta 2. Now I need to combine these terms, and in order to do that, they need to be like terms. I need to get this over a cosine theta 2, so I'm just going to multiply this by cosine theta 2 over cosine theta 2, and I'm going to say T1 equals F sub g over sine theta 1 cosine theta 2 over cosine theta 2 plus cosine theta 1 sine theta 2 over cosine theta 2. Now I can combine like terms. This is going to equal F sub g over sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2 all over cosine theta 2. Well, because we have this over this over this, this is going to flip up to the top, and this is going to equal F sub g times the cosine of theta 2 over sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. And I'm going to say this is still equal to T1 here. Now we're getting awfully close to what it wanted us to show, but we've got this big ugly thing at the bottom here. This is where it helps to go to MATLAB and look up your trig identities. It turns out that this whole thing, sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2 is equal to the sine of theta 1 plus theta 2. So if we plug that into the denominator of this fraction, we're going to end up with T1 equals f sub g times the cosine of theta 2 over the sine of theta 1 plus theta 2, which is what we wanted to show.